Okay, let's look at this rather difficult power series, DE. And what's going to make it more difficult is we have this x squared here in front of our y term. That's going to make it hard to match up our powers. We're going to have to go through a couple of extra steps here. So just like always, we assume y is a sum from n equals 0, a n x to the n. Here's y prime, here's y double prime. Notice I've numbered these because we're going to need them in a minute. Oh, sorry, here's y double prime. So here I wrote up y prime a couple of different ways. Since when I plug in n equals 0, the first term is 0, I'm allowed to just start counting at 1. And I did that so that I could raise all of these up by 1 and simultaneously drop this down by 1 so that I have an x to the n and I start at 0. That's usually my goal, having x to the n and starting at 0. Similarly with y double prime. Now we've gone through these steps a few times. So the first two terms would be 0 anyways. I might as well start counting at 2. That will allow me to raise all of these up by 2. Notice everybody, even the an went up to n plus 2, an plus 2. While I raise all these up by 2, I can drop my starting point down by 2 to balance that out. And now these two are equal. Okay, but now with regular y, when I have this 5x squared, I'm going to get an x squared times x to the n. I'm going to get an n plus 2 from this term. So when I combine everything together, I get this equation. In order to combine these into one single sum, I need the same power everywhere and the same starting point. That's impossible the way it looks right now. If I were to say drop all these down by 2 to make that x to the n, I would have to raise this up by 2. So this guy would be starting at 2. Well, these start at 0. And I could have done it that way and played the same kind of game. I chose to do it. I kind of have two choices here. Make these all n plus 2 or make them all n. I chose to make them all n plus 2. In order to do that, I want these to raise up by 2, which means I'm going to have to drop this down by 2. I can't go into negative n's. So I need to get rid of the first two terms here. I need to deal with n equals 0 and n equals 1 by themselves so that I can start counting at 2. Then I can make these guys here, these two, look like this one by raising up by 2, dropping down by 2. Okay, so like if I plug in n equals 0 everywhere, all the way across here, I'm going to get an x to the 0, an x to the 0. There I'm going to get an x squared. I'm only concerned with the x to the 0. Remember, the only way a power series can equal 0 for every value of x is if all the coefficients are 0. So the x to the 0 coefficients must be 0. I need to deal with those by themselves. So I'm plugging n equals 0 into just these guys because this guy doesn't have an x to the 0. If I were to write these out, his first term would be an x squared, then an x cubed, and so forth. He doesn't even have an x0 or an x to the first. So I'm going to plug in x equals 0 for all, or sorry, n equals 0 for all my n's. That's right here. See, a 0 plus 2, 0 plus 2, 0 plus 1, a 0 plus 1, 0 plus 1. Then I'm going to do the same thing for 1. Plug in n equals 1 everywhere in here, just these first two, because that would be x to the first. He doesn't have an x to the first. I don't have to worry about him. So I've plugged in n equals 1 everywhere in these first two, and I get this. That'll be all times x to the first. On the right-hand side, I have 0. That's 0x plus 0x squared plus 0x cubed plus 0, yeah, all zeros. So this first thing here in the parentheses must equal 0x to the 0. This second one here must equal 0x to the first. So just solving this thing equal to 0, that gets me A2 in terms of A1. Remember, this is second order, so A0 and A1 are going to be free. Those are my initial values. I'll never have an expression that determines those. Well, I should say usually won't. I mean, we could make up a DE where the solution, the only solution is y equals 0, and then obviously everything would be 0. But usually you won't have anything that determines A0 or A1. Everything will be based on those two. So this right here equaling 0 gives me A2. This part equaling 0 gives me A3 in terms of A1. Turns out they both give me something in terms of A1. Because this guy, see what I did here, this says A2 is negative A1. This told me A3 is negative 2/3 A2, but I just found A2 in terms of A1. Okay, then, now that I've done that, I've taken care of the first two terms here. I've dealt with the x to the 0 term and the x to the first term. So forget about those, I've dealt with them. I can start counting now at n equals 2. I've already dealt with the n equals 1 and n equals 0 terms. So I'm going to restart this guy at n equals 2. Now look what I can do. I can raise all these up by 2 and drop him down by 2 and get an x to the n plus 2 starting at 0, just like this one. Similarly here, I can play the same game here. I've already dealt with the first two terms. So start at 2, then raise all these up by 2, drop that down by 2. Then I can squish that all together. And now everybody has the same power and everybody starts at the same end. That gives me my recursive formula. And I end up with a recursive formula, an plus 4 in terms of an plus 3 and an. So it depends on two previous terms. The first two were free because it's second order. I just found these relationships from those first two terms, and this will get me all the rest of the terms. So I've just rewritten that so that I could use it. And I start plugging in values for n. Remember, n equals 0 is not going to give me A0. Don't get caught up on what you're plugging in versus what you're finding. When I plug in n equals 0, I'm finding A4. And I get these really complicated. Like I said, this was a hard power series. You can read through all the details here on your own. I get this expression or this equation for y. And it's perfectly fine to leave it like this. Sometimes you'll have a question that says, look, I want you to separate this into the A0 stuff and the A1 stuff. Other times you'll have a question that just says, look, find the power series, don't worry about separating it out. For a hard one like this, I think it would be better just to leave it like this. But I went ahead and went through the trouble of separating it out, finding all the stuff that has an A0 and calling that Y1, finding all the stuff that has an A1 and calling that Y2.